Okay, the next problem, we calculate the RL series RL circuit. RL series circuit and also the RC series circuit. RL RC series AC circuit. RLRC series RC AC circuit. Here is a resistor. Here is a capacitor. So resistor R, capacitor AC. So this is impedance Z can be calculated. Z equal to square root of R square plus AC square. In this case, this is a horizontal component. AC is this component. So resistor, capacitor like this. Now is a resistor inductor. So this is a Z. Resistor inductor is a this is R, this is HL. So this is impedance Z. Z can be calculated Z equal to square root of R square plus HL square. So in this case, this is a horizontal HL this one. So this will be the Z. So angle theta, this is angle theta can be calculated theta equal to tangent inverse AC by R. Here angle theta equal to tangent inverse HL by R. So this is the way we calculate for the resistor and the capacitor connected in series. In this case, this is the series RC circuit. Here is a series RL circuit. For the series RC circuit, impedance Z can be calculated square root of R square plus AC square. So this angle theta, so this we can draw a diagram here. This is the AC, this is R, so impedance Z, the angle theta. Theta equal to tangent inverse AC by R. For the series RL circuit, impedance Z can be calculated square root of R square plus HL square. Angle theta can also be calculated tangent inverse HL by R. So this is the way we calculate it. Then we saw the one problem. Determine the impedance of the series RL circuit consisting 220 ohm resistor and the 1.59 Henry inductor connected in series. So this will be the resistor. Resistor is 220 ohm. Inductor. Inductor is 101.59 Henry. So this is the impedance that need to be calculated. So the HL can calculate is a 2 by FL. So 2 into by 3.14 into frequency 50 into 1.59 into, so this is the way we calculate it. So HL can calculate it. So then we do the 314 multiplied by 1.59. This is 499.26. Oh, so, yeah. So then we calculate the impedance Z. Z equal to square root of R square plus HL square. The square root of R is 220 square plus 499.26 square. Then we calculate the resistance. So that will be 220 square plus 499/2 square. Square root. So 546 ohm. So this is the way we calculate for the inductor and the resistor. Connect in series, then we calculate it. Another problem. 120 ohm resistor connected in series with the 0.2575 ID inductor. Where to find out the current? So that in this case, the connection here, resistor is 120 ohm, and inductor inductor is 0.75 Henry. So this is the HL. So we need to calculate impedance Z. So that firstly we have to calculate HL equal to 2 pi FL. 2 pi 3.1416, frequencies are 50 and inductance 0.75. Then we calculate the HL. So HL can be calculated. The 314 multiply 0.75. So you got 235.6. Oh, so this is HL. Then impedance Z can calculate square root of R squared plus HL squared. So square root of resistance is 120 square plus HL is 235.6 square. 235.6 square plus 120 square. Square root, you got that 264.40. Then you got the current I equal to the V by impedance Z. So voltage is given the connect the supply. Supply voltage is a 415 volt supply. So this is we connect the voltage volt 415 volt. So the 415 volt divided by the impedance Z 264.4. So 415 divided by 264.4. So there will be the 1.57 ampere. So this is for the current can be calculated by this way. Then another problem, we need to calculate. This problem is 220 ohm resistor connected series with 22 microfarad capacitor. So the 220 ohm resistor is 20 connected series with the 22 microfarad capacitor. So here resistor and the capacitor. So the resistor is 220 ohm. Capacitor value is a 22 microfarad. So AC can be calculated. AC equal to 1 by 2 by SC. 1 divided by 2 by 3.1416 and frequency 50 and capacitance 22 into 10 power minus 6. Then we got the AC value. That will be the 10 power 6 divided by 314 divided by 22. So capacitance value is 144.750. The impedance Z can be calculated square root of R squared plus AC squared. So R is 220 square plus 144.75 square. So 1.7 square plus 220 square root. So that will be there 263 ohm. So this is a resistor we can calculate by this way. So in this case, if you see like this, you can also calculate. If the supply voltage is a 415 volt, you can also calculate the current. So how you calculate the current? I equal to V by Z. Voltage 415 volt, impedance 263. So 415 divided by 263, we can calculate the current. So this is 1.58 ampere. So the firstly we find out the capacity reactance. impedance, we find out the capacitive reactance by using the formula 1 by 2 by FC. Then we can do this, find the impedance, so square root of R square plus AC square. Then if you connect those are resistor, capacitor connected series to the supply, 415 volt to supply voltage divided by impedance, we can calculate the current. So this is the way we can calculate. With the next problem, RS series circuit. Current is 0.33 ampere connected to 32 volt supply. Where to find out the resistor and inductance. So this with this program, this RS series circuit. So this will be the supply voltage at 32 volt and 50 hertz. So in this case, it's given the phase angle. Phase angle is 60 degree. Angle is 60 degree given. So the current flow is at 0.333 ampere. So firstly, we have find out the impedance Z. Impedance Z equal to voltage divided by current. So voltage is at 32, current is at 0.333. So 32 divided by 0.333, we can find out the impedance Z. So 32 divided by 0.333. Alors, so that you can find out that this is 32.333, so you got a 96 ohm. Impedance is 96 ohm. Then we draw the diagram, impedance diagram. So this is resistor, this is inductor, inductive reactance. So this angle Z, impedance Z is a 96 ohm. This is angle theta. Angle theta is 60 degree. So the HL can be calculated. HL equal to Z sine theta. So Z is a 96 sine 60. 96 multiplied sine 60. We can calculate the impedance. So this is inductive reactance. So the sine 60 is a sine 60. 0.866 multiply 96, you got the 83.1 ohm. Then you can find out the inductive reactance. So HL equal to 2 by FL. Then L can be calculated HL by 2 by F. So HL is 83.1, 2 by F is 2 into 3.1416 into 50. Then we can calculate inductive reactance. So the 83.1 divided by 314. You got this 0.264 Henry. So this is 0.264 Henry. Or 264 millihenry. So inductance can be calculated. And resistance can also calculate resistance R. So Z cos theta. So impedance Z is a 96 cos 60. Cos 60 is 0.5. 96 multiplied 0.5, so you got a 48 ohm. So the resistance and inductance we can calculate by this way. Another problem. When connected to the 200 volt 400 hertz supply, RC series circuit draw at 2 ampere. Circuit phase angle is 45 degree. we need to find out the circuit resistance and capacitance. So in this case, this is the RC series circuit. Resistor, capacitor connected in series. This is resistor, this is a capacitor. So that the current flowing is at 2 ampere. We connect a circuit is a 200 volt. And supply frequency 400 hertz. So this is the way we got. And the angle theta is 45 degrees. So that firstly we can draw this Venn diagram. In this case, we can draw this impedance Z, we divide by I. So the voltage is at 200 volt, current is at 2 ampere, so this is 100 ohm. Then we draw this circuit diagram. So in this case, this is for the resistor component, this is a capacitive reactant component. This angle here, this is 45 degrees. So impedance Z. Z is we can calculate 100 ohm. So this is the angle theta here. So the R equal to Z cos theta. So impedance Z 100 cos 45. 100 multiplied cos 45. So that will be the 70.7 ohm. So 100 multiplied 0.707 equal to 70.7 ohm. So resistance value is 70.7 ohm. Similarly, the AC can also be calculated. AC equal to Z sine theta. So Z is a 100 sine 45. So 100 multiplied 0.707. So you got 70.7 ohm as well. This is the AC value. Then we can find out the capacitance value. So capacitance value is that we write down the equation AC equal to 1 by 2 by FC. And similarly, C equal to 1 by 2 by F into HC. So there we substitute. So 2 by F, 2 by is a 3.1416, frequency 400. AC value is a 70.7. Then this is for the farad. So if you want the microfarad, we can multiply with the this is farad. So if you want the microfarad 10 power 6 divided by the 2 multiply 3.1416 multiply 400 into 70.7. So this is the microfarad. So that we substitute here 10 power 6 divided by 2 divided by 3.1416 divided by 400 divided by 70.7. So we got is a 5 by 6 microfarad. The capacitance value is 5 by 6 microfarad we got. This is the capacitance value. The next one, when connected to the 50 Hz supply, RC circuit draw the 0.4 ampere, voltage draw across the resistor is a 16 volt, voltage draw across the ID inductor is a 12 volt. So we have to find out the total voltage supplied to the circuit, phase angle, resistance on the resistor, reactance on the inductor, circuit impedance, inductance for the inductor, and maximum power rated on the resistor. Those things has to be calculated. So this is the problem here. So this is a resistor and the inductor series circuit, RL series circuit. So this is resistor and this is the inductor. So resistor got the resistor R, inductor got the inductive reactance HL. So then we connected the circuit. So in this case, voltage draw across the resistor 16 volt. So this is VR is equal to 16 volt. And VL, voltage draw across the inductor is 12 volt. So this is also calculated. In this case, we can find out so resistor voltage and the inductor voltage. So this is the VR here. This is a VL here. This is for the supply voltage VT. VR. So in this case, we can find out the equation VT equal to square root of VR square plus VL square. So the VR is given the 12 16 square. VT is a 12 square. 16 square plus 12 square we calculate. So that will be the 16 square plus 12 square. The square root, you got a 20 ohm. 20 volt. Supply voltage is 20 volt, we calculate that. And phase angle, this is a phase angle theta. Theta can be calculated. Phase angle is tangent inverse VL by VR. Tangent theta equal to VL by VR, or the theta equal to tangent inverse VL by VR. So tangent inverse, VA is given the 12 VI system. So 12 divided by 16. So 12 divided by 16, we got 0.75. Then theta can be calculated. Tangent inverse 0.75. So inverse tangent 0.75. So this is a 36.37 degree lagging. We also need to calculate the resistance. Resistance need to be calculated. So in this case, current. The current drawing is a 0.4 ampere. This is IT. The current flow by supply is a 0.4 ampere. So in this case, we can find out the resistance. Resistance R. So this is IR equal to voltage drop across the resistor. Therefore, the I equal to voltage drop across the resistor divided by I. So voltage drop across the resistor is 16 volt. Current is a 0.4 ampere. So you can calculate. That will be the 40 ohm. And also the I into HL equal to VL. Therefore, the HL can be calculated. VL divided by I. So voltage drop across the inductor is 12 volt. Current is 0.4, so you got the 30 ohm. So resistor value is a 40 ohm. And inductive reactance value is a 30 ohm we got. Then we also calculate the impedance Z. Impedance Z equal to square root of R square plus HL square. So the R is, we calculate R is a 40 square, HL is 30 square. So this one we got the thing is a 50 ohm we got. Impedance Z, we got the 50 ohm. Inductance of the inductor, 2 by Fl equal to HL. So in this case, the inductor L can be calculated HL divided by 2 by F. So HL value is 32 by 3.14, and frequency of the supply is a 50 hertz supply because of the frequency is a 50 hertz. So 50. 30 divided by 3.14 and 50. So 30 divided by 3.14 and 50. So that will be the 0.96. 0.096 Henry, or 0. Multiply 10 power 3, so 96 millihenry. So this is the inductor we can calculate it. And also we can calculate power resistor. Power in resistor I square into R. So current is a 0.4 square. Resistance value we already calculated 40. So 0.4 square multiplied 40. So you can got that is a 6.4 watt. So the power equal to 6.4 watt we calculated. In another problem, when connected to 50 hertz supply, 80 ohm resistor connected in series with a 33 microfarad capacitor, current is 2 ampere. When you find out voltage apply to the circuit and phase angle. So that will be the resistor here and capacitor connected in series. So resistor value is a 50 ohm, resistor value is 80 ohm, capacitor value is 33 microfarad. The current draw is at 2 ampere. Where to find out the voltage? So firstly, we have to find out the capacity reactance AC divided by 1 by 2 by FC. 1 divided by 2 by 3.1416. Frequency. Frequency is given the 50 Hz supply. Capacitance 33 microfarad. Microfarad converted to farad, so multiply 10 power minus 6. So that will be 10 power 6 divided by 2 multiply 3.1416 multiply 50 multiply 33. Then we can calculate as a capacity reactance value 10 power 6 divided by 314 divided by 33. So we got the 96.5 ohm. So capacitor reactance is 96.5 ohm. Then we can find out the impedance Z. So supply voltage impedance Z, so we have to find. So the impedance Z is equal to the square root of R squared plus AC squared. So resistance is 80 squared plus 96.5 squared. Then we can calculate as our impedance Z. 80 squared plus 96.5 squared. The square root. This is 125. 125 ohm. And voltage we can calculate that I multiply Z. So I is 2 ampere, impedance is 125, so you got a 250 volt. Voltage is 250 volt, we can calculate. The next one will be the RLC circuit. So RLC series circuit is this is a resistor, and here is an inductor, here is a capacitor, and this is to the impedance Z. So if you connect the resistor, inductor, and capacitor, sometimes what happens is that inductor may be greater than capacitor. If HA greater than HC, what happens is that this is a horizontal is a resistor here. HA greater than AC. So this component is a vertical component, HL minus HC. So this is impedance Z, the angle theta. So we can write down the equation. Z equal to square root of R squared plus HL minus AC the whole square. Angle theta, tangent theta equal to HL minus HC divided by resistance R. So this is the power factor is lagging. From the angle theta, you can find out the theta, and the power factor is equal to cos theta, lagging. So this is a HA greater than AC. And also, this is resistor here, here is HL and the AC. So impedance Z can also be calculated. Sometimes what can happen is, if AC is greater than HL, in this case, we can draw the diagram, right? This is resistor here, this is AC minus HL. This angle theta. So impedance Z can be calculated square root of R squared plus AC minus HL the whole square. And tangent theta can be calculated. Tangent theta is AC minus HL divided by R. From here you can calculate theta, and power factor is leading. and cos theta. So this is for the RLC series circuit. We can calculate by this way. The first saturation is inductor value is inductive reactance greater than capacitive value. Capacitive reactance value, in this case we can draw the vector diagram like this. Then equation is Z equal to square root of R square plus HL minus AC the whole square. Angle tangent theta equal to HL minus AC by R. Then from here you find out the theta, and the power factor lagging is a cos theta. If there's a capacitive reactance greater than the inductive reactance, so we can draw a diagram like this. This is resistor, this is AC minus HL. So the Z equal to square root of R square plus AC minus HL the whole square. Tangent theta is AC minus HL by R. So from here you got the angle theta. So the cos theta is a power factor, is a leading power factor. So this is for capacitive reactance and inductive reactance circuit. We can calculate like this. Then we solve the one problem. (27-ohm resistor connected in series with a 250 millihenry inductor and 33 microfarad capacitor is connected to the 50 Hertz supply. We need to determine the impedance of the circuit. So this is the resistor here. Resistor value R is given 27 ohm. And inductor and the capacitor. Inductor is a 250 millihenry inductor. So A is a 250 millihenry. And the capacitor 33 microfarad. Then we need to find out the impedance. Okay, resistor here. Then firstly we have find out the HL. HL equal to 2 pi FL. So the 2 pi the 3.1416 frequency is a deep supply frequency given the 50 Hertz supply. So 50 and the inductance is a 250, but the millihenry to change to millihenry to multiply the more minus 3. So 2 multiply 3.1416 multiply 50 multiply 10 more minus 3. So this is the way we can find out the HL. So 2 multiply 3.1416 multiply 50 multiply 250 and divided by 1000. So you got 78.54 ohm. Inductive reactance is 78.54 ohm. Then we also see the capacitance reactance AC. A is equal to 1 by 2 by FC. So that in this case, we substitute 1 divided by 2 by 3.1416, frequency 50. And capacitance value is 33 microfarad into 10 power minus 6. So then we 10 power 6 divided by 2 multiply 3.1416 multiply 50. Multiply 33. So we calculate. So then we 10 power 6 divided by 314 divided by 33. So we got 96.45. Oh, so this is a capacitive reactance we got. So that in this case, you can see that AC greater than HL. AC greater than HL. So therefore, when the AC is greater than HL, there will be we can write down the draw the diagram. So this is for the resistor here. This is AC minus HL. So angle theta. This is impedance Z. So that Z equal to square root of R square plus AC minus HL the whole square. So that will be the square root of resistance value is given the 27 square plus AC minus HL. So AC is 96.45. HL 78.34. So that will be square root of 27 square plus 96.45 minus 78.34. 96.45 minus 78.34. The 18.11. So 27 square plus 18.11 square. And square root, so you got that 32.40. So this is the way we calculate that today's impedance for this circuit. The next problem. You have to find the supply current. If the 50 ohm resistor connected in series with the inductor with 60 ohm and capacitor with capacity rated 80 ohm connected to the 240 volt 50 hertz supply. So we have to find out the supplying current. So in this case here, resistor value given the 50 ohm. I is a 50 ohm. Inductive reactance and capacitive reactance. Inductive reactance is given HL, so this is a 60 ohm. Capacitive reactance is AC. AC is given 80 ohm. So we need to find out the impedance. Impedance need to be calculated. So this is connected to the 240 volt and 50 hertz supply. It's a connected. So we have to find the current. Current need to be calculated. So that these problems are AC greater than HL. So the big impedance diagram we can draw like this. This is a resistance. This is the AC minus HL. So angle theta. Here is Z. So write down the equation. Z equal to square root of R square plus AC minus HL the whole square. So that we substitute resistance R is 50 square plus AC minus HL. So AC is 80, HL is 60 square. So therefore square root of 50 square plus 20 square. So we find out 50 square plus 20 square square root. The 50 square plus 20 square. Square root, so 53.85. Oh, the impedance. The current can be calculated. Current equal to V by I, V by Z. Or the impedance Z equal to current equal to V by Z. We can find out. So in this case, voltage is at 240 volt. Impedance Z is 53.85. 240 by 53.85. So this is a 4.46 ampere. So this is the way we calculate the impedance Z. So impedance current is a 4.46 ampere. We calculate that. Okay, the next one is a 200 microhenry inductors connected in series with the 100 microfarad capacitor and unknown resistor. So the total current is a 5 ampere when connected to 240 volt and 50 hertz supply. Then we have to find the resistor value. So here resistor unknown, and here inductor and the capacitor. Inductor value is 200 microfarad. And inductor value is 200 millihenry. Capacitor value is 100 microfarad. So they are connected to the supply. The supply is at 240 volt, 50 hertz. So it draws the current 5 ampere. So firstly, we can find out impedance Z can calculate that. Z equal to the V by I. So voltage 240, current is 5. So that will be the 48 ohm. Impedance Z is 48 ohm we got. Then inductor and capacitor we have to calculate. Inductive reactance HL equal to 2 by FL. So 2 by 3.1416. Frequency is at 50. Inductance is at 200 milliampere. 200 into 10 power minus 3. So we substitute. That will be the 314 multiplied 200 divided by 1000. So 62.80. Inductive reactance is 62.80 ohm we got. Also that we can also calculate the capacitive reactance HC. 1 by 2 by FC. So the 1, 2 here by 3.1416, frequency 50. Capacitance value is given the 100 microfarad, 100 into 10 power minus 6. So that will be the 10 power 6 divided by 2 multiplied 3.1416 multiplied 50 multiplied 100. Then we can calculate capacitive reactance. 10 power 6 divided by 314.16 divided by 100. We got 31.8 ohm. So in this case, you can see that HL greater than HC. HL greater than, because HL value is 62.8, HC is at 31.8. HL greater than HC. So that in this case, we can draw a diagram. This is the resistor here. This is HL minus HC. So this is impedance Z. So this is the equation. So in this case, we write down the equation. Z square equal to R square plus HL minus AC square. So in this case, Z is, we know that Z is a 48 ohm. 48 square, R square plus HL. HL value is 62.8 minus HC. HC value is 31.8. The whole square. So the 48 square equal to R square. So that will be the 31. So from here you got R square equal to 48 square minus 31 square equal to square root of 48 square minus 31 square. Then we got the resistance R. So then we 48 square minus 31 square. Square root 36.6. So resistance value is 36.6 we got. So this is the answer. Okay, the next problem. So in this case, our resistor is 270 ohm. Inductor is 750 millihenry. Capacitor 20 microfarad. They are connected to the 450 volt and 50 hertz supply. So this is a problem here. Resistor, inductor, and a capacitor. They are connected in series. Resistor R is 270 ohm. Inductor L is given the 750 millihenry. Capacitor C 20 microfarad. They are connected in series. They are connected in series and they are connected to the supply volt 415 volt and 50 hertz. So this saturation. So we need to find out reactance of the inductor. HL need to be calculated. HL is equal to 2 by FL. So 2 by 3.1416, frequency 50, and inductance 750 millihenry. Because of millihenry, multiply with 10 power minus 3. So then we calculate, that will be the 235.6 volt. So this is HL. We also need to calculate reactance of the capacitor, HC. H equal to 1 by 2 by FC. So then 1 divided by 2 by 3.1416, frequency 50. Capacitance value 20 microfarad. So microfarad multiplied 10 power minus 6. So that will be the 10 power 6 divided by the 2 multiply 3.1416 multiply 50 multiply 20. Then from here, we can calculate capacity reactance. That will be the 159 ohm. Capacity reactance is 159 ohm. Then we need to find out the impedance Z. So in this case, you can compare the HL and AC. So HL greater than AC. Therefore, this diagram like this. This is resistor here. This is HL minus AC here. So this is impedance Z. So Z can be calculated square root of R square plus HL minus AC the whole square. So therefore, the resistor R is given the 270 plus HL value. HL is a 235.6 minus AC 159 square. So that will be this one we solve the 270 square plus 235.6 minus 159. 235.6 minus 159. So you got 76.6. So that square plus 270 square. And square root, that will be the 280.6 ohm. So impedance Z, we calculate that. Then we need to find out the current flow in the circuit. The current flow in the circuit I here, voltage is at 415 volt. I need to calculate that V divided by Z. The voltage 415 volt, impedance Z is at 280.6. 415 divided by 280.6, that will be 1.48 ampere. The 415 divided by 280.6. This is the 1.48 ampere. Current is 1.48 ampere flowing into circuit. And then we need to find out the voltage drop across the inductor. This voltage drop across the inductor is VL, voltage drop across the capacitor is VC, voltage drop across the resistor is VR. So VL need to be calculated. So I into HL. The current is 1.48. HL value we already know is at 235.6. 235.6. So therefore we calculate so that we multiply 1.48 multiply 235.6. So they are 348 volt. And AC, VC need to be calculated I into AC. I is 1.48. AC value. The capacity reactance value is we know is 159. So 1.48 multiplied by 159, we can calculate is at 235 volt. So voltage drop across the inductor is 348 volt, and voltage drop across the capacitor is 235 volt. And total supply voltage VD need to be calculated. VD is square root of VL square plus VC square. So in this case, our total supply voltage. Total supply voltage is a current multiplied impedance. No, this is for the supply voltage VD equal to current multiplied impedance. So current is given the 1.48. So resistor, voltage drop across the resistor is VR. So I multiply R. Current multiply resistance. So current is 1.48, resistance is 270. because we also need to find out the voltage drop across the resistor. Voltage drop across the resistor, current multiplied resistance. Current is 1/48, resistance is 270. So 1/48 multiplied 270, that will be 399 volt. And phase angle. This is phase angle theta here. Tangent theta equal to HL minus AC divided by R. So this is HL minus AC. HL is 235.6 minus AC is 159 divided by resistance R is 270. So this is the tangent theta. So 235.6 minus 159. That will be 76.6 divided by 270. So this is a 0.283. So angle theta can be calculated. Tangent is about 0.283. So this is 15.8 degree. So this is a lagging angle. 15.8 lagging. This is the we calculated. And another thing is that we have to find out the resonant frequency. Resonant frequency HL and AC are the same. We find out the resonant frequency. Series resonant frequency. At the time of series resonance, we can write down the equation that HL equal to AC. This is a series resonance. Series resonance HL AC. So the HL value is 2 by FL, AC value is 1 by 2 by FC. So we multiply to this side, so that will be the 2 by FL multiply 2 by FC equal to 1. There you can see that 2 square, pi square, F square, FC equal to 1. So the F square equal to 1 divided by the 2 square, pi square, and the SC square. Multiply SC. So frequency F equal to square root of 1 divided by 2 square, pi square, SC. So this is frequency F is equal to 1 divided by the 2 pi square root of SC. This F is a resonant frequency. Resonant frequency can be calculated by this equation 1 divided by 2 pi square root of SC. This is a resonant frequency. So that if the circuit here, resistor R is a 270 ohm, inductor is a 750 millihenry, capacitor C is 20 microfarad. We have to find out the resonant frequency. So we write down the equation F equal to 1 divided by 2 pi square root of SC. So this is a resonant frequency equation. So that 1 divided by 2, 3.1416. Square root of inductance. Inductance is 750 millihenry. 750 into 10 power minus 3. Capacitance is 20 microfarad. 20 into 10 power minus 6. So that will be square root of 1 by 6.28 square root of 750 into 20 into 10 power minus 9. So this is a 750 multiplied 20. 15000. So that will be 1 by 6.28 square root of 15000 into 10 power minus 9. So that will be square root of 6.28 square root of 15. 1 by 0, 10 power 3 minus 10 power minus 9. So this will be the 1 divided by 6.28. 15 into 10 power minus 6. So they will square root 6.28 square root of 15. 3.87. 10 power minus 6 is at 10 power minus 3. So therefore, 10 power minus 3 equal to here 10 power 3 divided by 6.28 into 3.87. So 1000 divided by 6.28 divided by 3.87. So we got there 41.14 hertz. So this is for the resonant frequency. It's at 49.14 hertz. We calculated. So this is what resonant frequency can be calculated by this way.